Okay, this is probably the first part of two videos going to be over systems of equations. I doubt I can get through all these slides in 15 minutes, so let's start. So systems of equations is basically two lines that you're graphing. If you have three possible solutions, they can intersect at one point like this, and here's the solution. They can be parallel, and then there's no solution, and then they can be on top of each other, and there's infinite solutions because they're the same line. Most of the time in the UI, though, they're going to ask you about that one intersection point. So this one says, what is the solution to the graph system of equations? And so the solution is just where they intersect. So this is 3, -2. So your answer is C. The graph shows two options to buy tickets for amusement park rides. Julie can pay $12 for a daily pass, or she can pay $1.50 per ride. For what number of rides is the cost of both options the same? Okay, and that's just going to be, what's the solution when they cross? It's going to be right here. So, for what number of rides if you come down, that's 8 rides. The next one, what is the y value of the solution to the systems of equations? What I always teach my students is if they ask for y, you want to get rid of x. And this one's already set up great for you to do that. This one, the students always get tricked though, so pay attention. Just start like you're adding, something normal, and you start on the right. 2 plus 4 is 6. I'm going to bring it down here. Negative x plus positive x is going to go away. That's what you want to do, and it's already set up for that. And then y plus y is 2y, so don't forget to add those together. Divide both sides by 2. Okay, if they also ask for the x solution, then you could plug one of these in, 4y, and solve for x. What is the x value to the solution? They're asking for x, so we want to get rid of y. So I have a 3y and a 1y. And so to get rid of them, we need them to be opposite of each other. And so we need to manipulate one of the equations, that way when we add them together, then we get rid of them. So I always ask my students, okay, they're asking for x, so we need to get rid of y. We have 1y and 3y. What's the easiest thing to do? There's lots of solutions, but what I would do is I would multiply this first equation by -3. Okay, then I'll have a -3y and a positive 3y, and then when I add them together, they go away. The big thing you need to remember, though, is when you multiply this equation by -3, you're multiplying each piece by -3. So I'm going to rewrite it. It's going to become -3x minus 3y equals -12. Okay, and then we're going to write the other equation that we did not change right underneath of it. 2x plus 3y equals -2. Okay, and now we can add them up. -2 plus -2 plus -12 is going to be -14. We have these cancel out, which is perfect. -3x plus positive 2x is going to be -1x. Okay, we'll divide both sides by -1. And x equals 14. Okay, so Matt starts with $15 and saves $10 a week. At the same time, Julie starts with $45 and saves $5 a week. In how many weeks will they have the same amount of money? So since they're going to have the same amount of money, we're going to set those equations equal. Remember, anything that's like per week or something like that's going to be times your x, and then your starting point is going to be like your y-intercept. So for Matt, his equation is going to be 10x plus 15 equals, and Julie's equation is 45 because she starts with $45 and she saves 5 per week. So you could plug these in and see which answer is going to get you the one that makes them equal, or you could also solve for x. So I'm going to solve for x, and I can also show you the other way. So one of them x subtract 15 from both sides. So let's get 5. So the answer is 6. Okay, you also could have gone through and plugged in and solved which one would gives you the same answer. If you put in 6 on this side, you would get 60 plus 15, which is 85. If you put in 6 on the other side, you get 5 times 6, which is 30 plus 35. So, so you could also do it that way. The important thing here to understand is a week or per week, so that's always going to be multiplied by your x, and then this is where you start. And then we want them to have the same amount, so we're going to set those equations equal. Look at the system of equations below. What is the y value? Okay, so they want to know your y, so you can get rid of the x. This is a little tricky and sticky. A lot of times but it's easier to do. So we don't have something else. We can make them both equal 12. So we can multiply the top equation by 2 and the bottom equation by 3, which might be what I do. If you don't want to think that far, the other thing you can do is you just want them to be the same number but opposite. So one's positive, one's negative. So a lot of times I'll just multiply them by the other number. So multiply this top equation by positive 4 and this bottom equation by 6. Since it's already negative. You could also do that, so then you have 24 and 24. That works as well. So, but I think I'm going to get them to 12. So I'm going to multiply this top equation by 2 and this bottom equation by 3. That way I have a positive 12 and a negative 12. And then we want to rewrite the equations. Remember, we're getting rid of our x because I want to know the y value. It just saves you time, because if you get rid of the y, then you have to go find it later. It's just extra steps that you don't need to do. So 12x minus 14y equals 40 will be the new top equation, because remember, you need to take that 2 and distribute it into everything inside. Okay, and then on the bottom, you're going to have negative 12x plus 9y equals negative 60. You're just going to add them up. Positive 40 plus negative 60 is going to give me negative 20. Negative 14 plus positive 9 gives me negative 5y. Those cancel out. I divide both sides by negative 5 and I would get positive 4. Tamika would like to go fishing at one of the 2 catfish farms close to her house. Floyd's Catfish Farm charges a fee, $5 fee to fish plus $2 per pound. Miller's Catfish Farm does not charge a fee to fish, but just charges $3 per pound. The graphs of the costs of equation for 2 catfish farms intersect. What information does the point of intersection represent? The number of pounds of fish caught at both catfish farms for the same price. The number of pounds of fish caught at each catfish farm for the day. The amount of money saved by going to Miller's Catfish Farm, or the cost for 1 pound of fish caught at each catfish farm. Okay, the answer is going to be A. Where they intersect is going to be the number of pounds where it costs the same, because that intersection point is the same point for both lines. So remember, where they intersect is 1 point, so exactly the same. Joan graphed the lines y equals 4x plus 2 and y equals 2x minus 6. What is the y value of the solution to the system? So this really isn't the proper way to do it. So you could solve one for the other and substitute it in. Let's try doing it this way. Okay, I'm going to multiply the second equation by -2. That way when I add them together, my x's will go away. Okay, so technically, probably a proper math teacher would tell you it needs to be x plus y equals a number. Honestly, if you have them all lined up correctly, you don't have to do that. So positive 1 plus -2 is going to give you -y. Okay, multiply the second equation by -2. That way my x's canceled out because they're asking for y, so we can get rid of x's. And 2 plus 12 is 14. I'd have to divide both sides by -1 to get y by this. So y equals -14. A corporation purchased a company for $50,000. The cost to run the company averages $1,000 per month, and the revenue is $2,000 per month. The equation below shows this situation where T is the time in months. How long does it take for it to break even for the revenue to equal cost? So we'd have 2,000 T equals 50,000 plus 1,000 T. You could plug numbers in and see when you put in 40 on both sides, do you get the same number? If you put in 45 on both sides, do you get the same number? You could totally do that, or you can solve it for T. And we subtract 1,000 from both sides, so this would be 1,000 T equals 50,000. Just subtract that from both sides. Okay. And then we just do 50,000 divided by 1,000, and we would get 50. So your answer C. Like I said, you could also plug them in and see which one will get you the same answer on both sides. So this is part 1, and I'm going to do one other short video to kind of finish these up and systems of equation.